Hey, Algebra 2 Honor students, this is Unit 13, Day 2. Today we're going to extend our knowledge of the three basic trig functions to talk about. Yes, 6 different trig functions. We already know SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. But today what we're going to talk about are the names for what are called the reciprocal trig functions. So what we're going to do is I'm going to draw an arrow this way, and I'm going to say that all of these, because we talk about the reciprocal functions actually quite a bit, we give them special names. So the reciprocal of sine is a function called cosecant. And cosecant's abbreviation is CSC. So if I were to do cosecant of theta within a specific triangle, instead of doing opposite over hypotenuse, we're going to do hypotenuse over opposite. And similarly for the others, if I have cosine, cosine's reciprocal function is called secant. And the abbreviation for secant is SEC of theta. So secant of theta would be the reciprocal of cosine, hypotenuse over adjacent. And then finally for tangent, we have its reciprocal. This one I think makes the most sense name-wise. It's cotangent. And for cotangent's abbreviation, we have cot. Okay, cotangent of theta would be the ratio, flip this over, adjacent over opposite. So these three are ones that we're going to have to become just as familiar and comfortable with using as we have for the first three, sine, cosine, and tangent. So if we have those three down, let's just talk about some equivalencies here. If I gave you, let's say sine of theta is equal to -4/7. What I know is that cosecant of theta, its reciprocal would be -7/4. Just flip it on over. If cotangent of theta is equal to radical 3, what would tangent equal? Okay, we can go backwards with this too, right? If I have the cotangent, if I have the reciprocal already, if I flip this over, I'll get tangent. Well, think of that as radical 3 over 1. Tan would then be 1 over radical 3, which you can then rationalize to get radical 3 over 3 if you want to get fancy there. That might be something we do pretty commonly, but first and foremost, just flip it over and get 1 over radical 3. And finally, if I gave you secant theta is equal to 2, what would cosine theta equal? Well, cosine theta would equal 1/2. Because again, if we write this as 2 over 1, flip it over to get the ratio for cosine of theta. And what that brings us to is an example where we can find the value for all 6 trig functions. So let's find the value for all 6 trig functions for angle R in standard position. And this is just a lot of fancy language. I'll explain what all this means in a moment. Okay, so find the value for all 6 trig functions for an angle R in standard position with point Q on the terminal side. And I'm going to define the point Q for you here as -8, 15. Okay. So what we're going to do is we're going to be sketching angles today in just a few minutes. And when we sketch an angle that's in standard position just means it's within one of the 4 quadrants. Essentially, the angle is somewhere from 0 to 360 degrees. Okay. And what I'll tell you is when we sketch angles, the initial side is always essentially the side along the x-axis. And if I were to sketch an angle, let's say that was in quadrant 3, this side where that angle ends, this is the terminal side of the angle. So when I mention the terminal side up here, we're saying that some point is on the terminal side. It's on the side where the angle ends. So if I think about where -815 is located, -815 is definitely a point that's in quadrant 2. So if you were to sketch a picture here, we would have an angle that, again, start with the initial side on the x-axis. We're going to rotate somewhere into quadrant 2. And I'm going to stop such that when I draw on the terminal side right there, okay, so it's rotating around this way. When I get to that terminal side goes through the point -815. And we want to figure out the value for all 6 trig functions given this picture. Well, as soon as you draw on that terminal side, the first thing I'm going to tell you is that you're going to draw a line down to the x-axis. We're going to make a right triangle with the x-axis. And what I know is that this side right here is to the left 8, so I'm going to label that as -8. And then the side that goes up is 15. I mean, that makes sense. To get to the point -815, we have to go left 8 and then up 15. So in order to find all the trig function values, by the way, I'll label this as my angle R right there. Okay, even though I guess technically this part's angle R, the value for sine, cosine, tan of angle R are all going to be based off of this triangle right here. So if I start setting that up, that if I want to do sine of R and cosine of R, and then tan of R, we'll need very quickly here the length of this hypotenuse, won't we? Because sine is going to be opposite over hypotenuse. That would be 15 over, well, got to find the hypotenuse. To find the hypotenuse, you're going to use some Pythagorean theorem. -8 squared plus 15 squared would equal c squared. And just to save us some time, because I'm trusting that you're all excellent Pythagorean theorem completers, this length would be 17 right here. Okay, and it turns out 8, 15, 17 is just another Pythagorean triple. So sine would be 15/17. And then we can go on, and now that we have that filled in, fill in cosine. Cosine would be adjacent over hypotenuse, -8/17. And then finally, tangent would be opposite over adjacent, 15 over -8. So that's 3 of my functions, because I did say find the value for all 6 trig functions here. So then the last piece is, of course, just writing those reciprocal functions in: cosecant of R, secant of R, and finally cotangent of R. And there's not that much more work involved here. Could I go back and say, let me do hypotenuse over opposite for cosecant? Hypotenuse over opposite, 17 over 15. We could, but we already know we're just going to flip the ratio for sine. So if I flip the ratio for cosine, secant would be -17/8, and finally tangent would be -8/15, something like that. Okay, so we should be able to, given a point on the side where the angle ends, which is called the terminal side, we can go ahead and figure out the value for all 6 trig functions. All right, moving on to some more practice here. Things are about to get a little sketchy here. And what I mean by getting sketchy is I mean we're going to sketch some angles that are specific. So when sketching angles, if you have a positive number of degrees, that means you're going to start on the initial side, start on the positive side of the x-axis, and you're going to go counterclockwise from there. Think about angles of rotation in geometry. This would be a very similar pattern, that we would start and we would go in a counterclockwise direction if it's a positive number of degrees. If you have a negative number of degrees of rotation there, you're going to start in the same place, but now you're going to go clockwise. Okay, so when I go to sketch angles, it's probably important to think about kind of where those borders are. Okay, so 0 degrees, the initial side of the angle is always going to start here. So if I rotate counterclockwise, this would then be 90 up here. And if I go a half circle, that would be 180 degrees. 3/4 would be 270. And then finally back to where we started is 360. So if I gave you an angle that was somewhere, within those border lines of those quadrants, we should be able to sketch those angles pretty easily. So let's actually get some practice here. If I said to sketch an angle of 120 degrees, what quadrant would that angle be in? Well, hopefully you'd be able to pretty quickly tell me the answer. An angle of 120, if this is the initial side, you're going to rotate around counterclockwise into quadrant 2. Draw on the terminal side. This angle is 120 degrees. So this angle is definitely in quadrant 2, if I ever ask you what quadrant we're located in. How about something like 305 degrees, thinking about the quadrant that terminates in? So 305, let's see, I could always come back up here to kind of remind myself that 305 is between 270 and 360. So if you start here, you're going to rotate around counterclockwise, end in quadrant 4. Okay, that's what an angle of 305 looks like when sketched. Okay, how about negative 190? So remember that if the angle is negative, all that means is you're going to go 190, but you're going to go in a clockwise direction. So if I go here, that's 90 degrees. If I go half circle, I know that that's 180. So I need to go another 10 degrees, which brings you into quadrant 2. The quadrants do not get relabeled when you sketch in a clockwise direction. This is still 1, 2, 3, and 4. Okay, so this does end in quadrant 2, just like the first one. But negative 190, we just have to make sure we go in a clockwise direction. And then finally, what about like 775 degrees? Where would that be? Well, if the angle is bigger than 360, all that happens is it just keeps rotating around the axes, and it will eventually stop. But if I go 360, that's one complete revolution, right? And then could I go another full revolution and make another complete trip around? Turns out we can go another full revolution, because now I've gone 360 and 360 is 720, right? So we've gone a total of 720 so far, 360 plus 360. I guess how much further do I have to go to get to 775? Well, 775 minus 720, that's going to get me into what's called standard position. We need to go another 55 degrees from here. So if I go another 55 degrees and sketch in that terminal side, 775 happens to be a quadrant 1 angle. It happens to be in the same exact location as an angle that has 55 degrees in it. It just rotated around a couple times before it got to that same exact stopping place. Okay. And this will help us later on in some other stuff that we do with trig. But being able to sketch angles is pretty important. Okay. So the next thing I want to talk about is, where are our trig functions positive and negative? And to answer this question, I want to refer you back to the example from the beginning of the lesson where we had the terminal side through the point Q, which was in quadrant 2. Notice how when I was in quadrant 2, sine and cosecant, those reciprocal functions, those are positive. But cosine and tangent both had negative ratios, right? So I want to figure out, how do I know where certain trig functions are positive and where certain trig functions are negative? So in order to determine that, I'm going to have you consider the following. If you have a right triangle in any of the 4 quadrants, if we think about how we would label the sides, okay, in quadrant 1, we're going to get to this point right here. We're going right, and then we're going up. When I go right and up, both of those are positive directions. So what I'm going to do is I'm going to put the letter A in quadrant 1. We'll talk about why that's the case in a second. We saw what happens in quadrant 2. In quadrant 2, we know that sine is positive, but the other 2 were negative. Okay. And the reason why is that when I go to the left, that's a negative direction, but going up is positive. So what letter am I going to put in quadrant 2? I'm going to put the letter S. What does that mean? It means that only sine is positive here. Cosine and tangent would both be negative in quadrant 2. Why is that the case? Well, sine is opposite over hypotenuse. That's going to be the ratio of 2 positive lengths. Whereas cosine and tangent, which use the adjacent side, because we're going to the left, we're going to consider that a negative direction. And therefore, that ratio will turn out to be negative. Finally, when I go down into quadrant 3, what's going to happen is the only one that will turn out to be positive here is capital T for tangent. The reason why is that if I'm going left and down, those are both negatives. But when I do opposite over adjacent, a negative over a negative turns out to be positive. Tan is the only one that's positive in quadrant 3. And finally, in quadrant 4, if I'm going right and down to get to this point right here, the only one that will be positive is the one that uses adjacent and hypotenuse. I don't want to use that opposite side. Well, adjacent and hypotenuse, of course, is C for cosine. So it turns out that in quadrant 1, all the functions are positive. Every single trig function is positive in quadrant 1. But like we said, in quadrant 2, only sine is positive or cosecant, it's reciprocal. The other two functions and their reciprocals would be negative. In quadrant 3, because we said opposite and adjacent, the negative over negative would become positive. Tan is positive, and so would cotangent. And finally, in quadrant 4, cos is the only one that's positive, and it's reciprocal secant. So we're going to get into this in just a few moments, where we use this idea to help us decide whether we're positive or whether we're negative in the end. But the best way that you can remember this, as far as where certain trig functions are positive and where certain trig functions are negative, is for the next couple weeks of trig, you are going to be my all-star trig class. Okay? ASTC, all, sine, tan, cos, all-star trig class. That's it. You're going to hear me say this a lot. Okay? So in my all-star trig class, you're going to use this information to determine where trig functions are positive and where they are negative. And this takes a little while to get used to, but I promise with some more examples, you will get the hang of it. All right, let's take a look at the following examples. I want you to, in each example below, express as a function of a positive acute angle. Okay, emphasis on positive, emphasis on acute. Okay. Here's the first example we'll take a look at. Sine of 210 degrees. So all I want us to do for this is express this as a positive acute angle. So in order to do that, first thing I want to do is sketch the angle of 210. So for each of these examples, you're going to sketch where that angle would terminate. And 210, here's the initial side. Since it's positive, you're going to rotate counterclockwise. 210 is going to terminate in quadrant 3 somewhere, right? Because it's somewhere from 180 to 270. Well, what I want you to determine is, if I were to draw this triangle that connects back to the x-axis here, what is this angle right here? What's that little part that's in the third quadrant? And that piece right there, by the way, is called the reference angle. Okay. So the reference angle, let's think of this. I've gone 180. How much further do I have to get to 210? Or take the full angle 210, subtract 180. Isn't this reference angle 30 degrees? However, you are an all-star trig class now. And because you're in an all-star trig class, what do we know about quadrant 3? We know that the bell is ringing. But we know, most importantly, that other than the bell ringing, that tangent is the only one that's positive here. So if I'm dealing with sine and I'm in quadrant 3, I know that the answer should be negative. And we're going to express sine of 210 as negative sine of 30. Now, when I say a positive acute angle, it means the angle on the inside has to be positive. But because we're in quadrant 3, you have to negate the outside of this function to make this a true statement. And if you don't believe me, let's check it out. Ready? Sine of 210 actually has quite a nice value. This doesn't always happen. It's negative a half. If you were to type in negative sine of 30, guess what you're going to get? Negative a half. So those are, in fact, equivalent. That's what I'm trying to do, is just re-express this in terms of a function that's a positive acute angle. However, because sine of 210 altogether would be negative, we have to negate the outside of sine 30 to create an equivalent expression there. Take a little while to get used to it. Let's try another one. If I gave you cosine of 345. First and foremost, let's figure out where 345 degrees is. Okay. 345 is almost full circle. Pretty close. What I want you to think about is actually, how much more would I need to go to complete the circle? Because that's the reference angle that I want you to find. Just found a reference angle up here. The reference angle is the one that's connected to the x-axis always. So think of it as full circle is 360. 360 minus the angle that we sketched, 345, leaves you with a tiny 15 degrees. Okay. So what do I know? I know that cos of 345 is equivalent to cosine of 15. But do I have to negate that? Well, you are my all-star trig class. What do you know about cos in quadrant 4? Cos is positive here. Therefore, this final answer is positive. And just to do that really quick check again, is cos 345, this will not be a nice decimal, by the way, 0.9659, is cosine of 15 the same thing? Meaning I didn't have to even negate it. The answer is yes, it is. So we're just trying to re-express this large angle in terms of a smaller angle that tomorrow we'll be able to work with a little bit more easily. All right, what about tan of negative 200 degrees? Well, starting with negative 200, that's already not so great because we don't want negative angles at all. All right, let's see, negative 200. So if I go from 0, we're just going to rotate around clockwise, right? This would be 90. This would be 180. So we have to go a little bit further into quadrant 2. Okay. Now remember the reference angles, this little part that's connected to the x-axis right here. So if I've already gone 180, how much further do I have to go to complete 200? Hopefully you're shouting out 20 degrees. 180 plus 20 would get me 200. Tan of negative 200 is the same thing as, oh wait, hold on, all-star trig class. We're dealing with tan, and we're in quadrant 2. What do we know about tan in quadrant 2? It's negative. Okay, and if you are unsure about this, check it on the calculator. Even though they're crazy looking decimals, type those things in and see if they get you the same decimal. Hopefully they do. If not, we made a mistake somewhere. The answer is negative tan 20. We got to negate it because only sine is positive there. Last one we're going to do is secant of 565 degrees. Oh boy, 565. All right. We know that when the angle is bigger than 360, it just rotates around the axis more than once, right? So it makes one full circle, and then it's not going to make a second full revolution, is it? Because that would be 720 degrees. So let's see, if I subtract out that one full circle, it leaves you with 205. So it's going to circle around again, but it's going to stop in quadrant 3 somewhere. It's gone another 205 degrees. Okay. Might as well do all-star trig class now so I can think about whether it's positive or negative. Okay, let's find this reference angle. Now remember, how far did I go in here? I went a total of 205. Halfway around is 180. How much further do I have to get to 205? Another 25 degrees. So this is the same thing as secant of 25. Do I have to negate it? Secant's the reciprocal of cos. Well, only tan and cotangent would be positive there, so we do have to negate this. Okay. All right, there's the bell again. Really quickly, how do I check something like this on the calculator? To do secant, you would type in 1 over cos. So there's the answer for 1 over cos. Let's see, is that the same thing as negative 1 over cos of 25 degrees? I really hope it is, and look at that. So if you're unsure, definitely feel like you can check it on the calculator. However, those decimals will never be the answers. This is what I'm looking for right here in terms of a positive acute angle. All right, that is it for today's lesson. We will do more practice like this next time we're in class. Have a great rest of your day.